By the way, here's a good way for you to document your requirements in case someone asks you to create a bunch of tables. Always have the field, the data type, whether or not it's required, whether or not the columns are unique, and of course other metadata, but manage a sound documentation so that anyone can read it easily. So here's a table, a dictionary table. It has a word, meaning, a part of speech, so you can have things like noun or verb, whatever, and then an example. So let's create a table for this fictional dictionary table. The search in the application is restricted to just the word field. So let's assume that you have, say, like an Android device and you're trying to create a dictionary, and this is the structure of your table. One thing to notice is the table creation script will be called exactly once by the framework, and another assumption to make is varchar of n occupies n bytes. So these are things that I want you to keep in mind before you create the table. Go ahead and give it a shot. Here's the solution. So we create a table called dictionary. Word is varchar 10, and then we have meaning varchar 20, part of speech, and then an example. Here we're using without row ID modifier. Why is that? The size is 30, 60, 80 bytes, which is less than 0.2 KB. So we can use without row ID, and we also know that the search is going to be restricted to just the word, and most importantly, word is required and is unique. So we have our primary key column. We can specify it here. Also notice that that's the reason why we don't have a not null modifier here. Since word is now a primary key of a without row ID table, the not null constraint is automatically enforced by the SQLite engine. For the rest of the columns, we have to explicitly specify not null as part of them. Example is not required. That's the reason why it doesn't have the not null modifier. That brings us to the end of the first quiz. Oh yeah, one thing to notice is we don't have the if not exists modifier because the table creation script will be called exactly once by the framework. Yeah, now for real, that's about it for the first quiz. Similar to a primary key, there is also a unique constraint. It is identical. The only difference is you can have multiple unique constraints per table, but you can have only one primary key constraint. In most cases, both primary key and unique key constraints are implemented by creating just a unique index on the database. Of course, exceptions are integer primary key and primary keys on without row ID tables. We saw how they were organized. Each row must contain a unique combination of values as identified by the unique key constraint. This is points 3, 4, 5 are identical to a primary key. So as we saw before, nulls are considered distinct from each other and they're allowed. And finally, must contain only column names. That is, you can't afford to have expressions as part of your primary key or your unique key. Let's now move to the second quiz. Change your table create statement based on the information below. A word can now have one or more parts of speech. Here's a hint. You can have more than one column in a primary key definition. Let's look at the solution. We have the same create table statement without the if not exists. Then we have a word, meaning should still not be null, the part of speech, the example. Here you'll notice a change. The primary key will now be a composite primary key, including both the word and part of speech. Since they are part of the without row ID table, they need not be declared as not null explicitly. The constraint is automatically enforced. Here's one more quiz for you. Change your create table statement based on the information below. An example can now hold up to 4,000 characters. You may assume that 4,000 characters translates to 4 kilobytes by just this example field. Another thing is an example is unique across the entire table, being the dictionary table here. A hint, think about the entire row size. If this field alone is going to cost you 4 kilobytes to store, and reevaluate your decision to use without row ID constraint. Here's a solution. We now have the without row ID phrase gone. Now the not null checks are back, and finally You can have it either as a primary key or a unique key. It doesn't matter because you're going to have a row ID with integer primary key automatically defined and managed by the dictionary table, rather the SQLite engine for the dictionary table. The change in schema will be here. Now the example is varchar of 4000, and of course we add the unique constraint. Why the unique constraint and not a primary key? You already have a primary key, and here you can mention it as a unique key, and of course you can have more than one unique constraint enforced on a table. That brings us to the end of this quiz.